All right, welcome class. Today we're going to learn how to prove that lines are parallel. This is Mr. Giovanelli with you. Our essential question today is how can we determine if line segments are parallel and we're still working on a coordinate plane just like in our last lesson. We're under the same standard here and we're going to really start to see this one come into play. We're going to prove or disprove geometric figures. So we're going to be able to prove or disprove if something is like a rhombus or a parallelogram, things like that. Desmos is always your friend. You know that. Okay, this is the same warm-up from yesterday, but I just wanted to show you that we're going to be focusing on a different aspect of this, kind of a different piece of the puzzle. So if this is a rectangle, what qualities would it need to have? Yesterday we talked about opposite sides being congruent, right? We talked about using the distance formula to prove that. Today, what we want to do is let's learn how to prove that opposite sides are parallel. So if this is a rectangle, its opposite sides are parallel. We want to learn a mathematical way for how to prove that. All right, let's just review really quick again. What is parallel? So definition of parallel lines are two lines that lie in the same plane that never intersect. So here you have an example of lines L and M and N, are considered parallel. They're in the same plane and they're not going to intersect. For our class, though, for this unit rather, we're going to be on a coordinate plane. So do these lines intersect? Are they parallel? Well, how do we know? One way that you might remember on how to calculate this, if you have the graph in front of you, is you can count the slope. So if you pick 2 points on this line, I'm noticing that the slope here is up 2 over 3. And then I can find that the bottom line has the exact same slope, 2 over 3. So these lines are in fact parallel because they have the same slope. Okay, now that's great if we have a picture, right? But we also want to know how to calculate slope and know if lines are parallel, even if we have no graph at all. So let's try that. So here we go. We've got line CD has a slope of 4. Remember the symbol for slope is m. So by saying m equals 4, that's saying the slope is 4. If you wanted to write that as a fraction, you could say 4 over 1. If A is at negative 4, 3, and B is at negative 6, negative 5, is line AB parallel to line CD? So to answer this question, we're going to use the slope formula. So the slope formula, you might recall already, is the change in y's over the change in x. So y2 minus y1 over x2 minus x1. So let's use a similar tactic from yesterday. Let's label these x1, y1, x2, y2. Actually doesn't matter which one you call 1 and 2. You could have this flipped and you'd still get the same answer, but it's easier just to label the first one x1, y1. Okay, so let's plug this into our formula now. So y2 minus y1, you're going to have negative 5 minus 3. x2 minus x1 is negative 6 minus negative 4. Okay, one thing to keep in mind here, be really cautious about your negative signs, okay? You're adding and subtracting positive and negative integers here. So negative 5 minus 3 is negative 8. Negative 6 minus negative 4, that's going to turn into a plus. So that's going to get you to negative 2. Negative 8 divided by negative 2 is in fact positive 4. So these lines are parallel. So we could say AB is parallel to CD. And the reason is because their slopes are the same. All right, if you had graphed it, which you could have done, you could have graphed it, you would have got a line that looks like this. By the way, if you want to learn how to make line segments on Desmos, check my other video. I have another video on this that just shows you how to do that, how to make basically these points connect. But if you had graphed that, if you knew how to do this already, you could see that if we start here, we go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. The slope is also 4 over 1. So just another way to prove it. Now, one thing about using slope by counting it, you have to kind of think about whether the line is increasing or decreasing to know if it's positive or negative. So because this line is going up from left to right, I know that it's a positive 4 over 1. By using the formula, you don't really have to think about positive or negative. So that's another advantage of the formula. Okay, this you can add to your notes. Here's the slope formula, which we just talked about. And then the big concept of today, lines that have the same slope are parallel. So if we're trying to prove lines are parallel, you're going to calculate the slope. You can find slope using the slope formula, which I recommend, or if you're a very visual person, you can count the rise over run if you graph it on Desmos. Okay, what we're studying here is called coordinate geometry. It's the application of geometric ideas on the coordinate plane. What we're going to try to eventually do is use coordinates to define shapes and figures. So we want to be able to like prove a figure is a specific shape. To be able to do that, we have to make sure it meets all the requirements of that shape. So one of the things we're going to have to be is familiar with the properties of shapes, mainly quadrilaterals. All right, so you're going to see some things from previous units come back into play here. Okay, let's do a practice problem here. So these 4 points, A, B, C, and D, they form a quadrilateral. Now let's say we were asked to show that these form a rhombus. So what are some qualities a rhombus must have? Well, one of them is that all sides are congruent. That's one big piece of a rhombus. So we would have to show that. And then another quality of a rhombus is that opposite sides are parallel. All right. There's some other things we could say about a rhombus, but those are the two that we really are going to focus on when we use coordinate geometry, because those we can prove with coordinates pretty quickly. Okay, we would have to prove that all 4 sides are congruent. Now, this is basically we would use the distance formula here, or Pythagorean theorem, all right, which was the focus of our last lesson. So I want to save us a little time here. All 4 sides are in fact congruent, and if you want to see why, you'll notice that we can draw a 3x1 triangle around every single side. So I could do the distance formula 4 times, or Pythagorean theorem 4 times. Each time it's going to be 3 squared plus 1 squared equals c squared. So 9 plus 1 equals c squared. So the distance of every single side is going to be the square root of 10. So each side of this rhombus is the square root of 10. Okay, I know I went through that quickly, but just because that's not the focus of today's lesson, you already learned distance formula. Let's just take my word for it. Each side is the square root of 10. Okay, so we've proved that the opposite sides are congruent, but we haven't really shown this as truly a rhombus yet until we can show that the opposite sides are parallel. So what we're going to do is we're going to consider the slope of each line, and then we'll see what we get. So I'll do the first one. I'll do AB, and then you guys could pause it and do the next two. So if we're doing the slope of AB here, I recommend you label your points, especially if you're someone who likes to stay organized, x1, y1, x2, y2. And now we'll do y2 minus y1, 0 minus 3, over x2 minus x1, negative 1 minus negative 2. So if we simplify that, again, be real cautious about your negatives here. That becomes a positive. We have negative 3 over 1, which is just negative 3. So the slope of this first line is negative 3. Now I suggest you pause the video here and work the other 3 out on your own before I reveal the answers. Okay, if you worked it out here, you should have found, if you did the slope of BC, you would have done negative 1 minus 0 over 2 minus negative 1. So you would have gotten negative 1 over 3, or negative 1/3 here. And then these two answers should have repeated for the other two slopes. So the slope of CD is also negative 3, or negative 3 over 1. And then the slope of DA is also negative 1 over 3. So this is exactly what we wanted to show. This is exactly what we wanted to find. What we've proven here is that the opposite slopes are the same. So in other words, this is mathematical proof that the opposite sides are parallel. This is how we can know that for sure. So we've really done a solid job now of proving that this is a rhombus. Opposite sides are congruent and opposite sides are parallel. Okay, you might be like, man, I didn't remember anything about a rhombus. So one thing that I want to point out to you is that you're probably going to want to review some of these properties of quadrilaterals. So here's that family tree that we kind of put together earlier in the year. There's also this slide here that I'll show you and offer you that you can return to. This just kind of breaks down each quality of the shapes. And I want you to kind of focus on mainly the sides aspect of it. So we want to talk about the sides. When we do this coordinate geometry, we're going to be able to prove things about the sides the easiest, okay? But these other qualities that you see listed are also true. All right, now we have the skills basically to take any shape, any quadrilateral, and make some decisions about what type it might be. So we're given quadrilateral AFHS here, and just based on the slope, we only are going to look at the slopes. What type of quadrilateral do we think AFHS is? So I'll do the slope of AF, and then I'll have you pause the video and you can do the rest. So here we go. Just doing AF, we'll label our x1, y1, and our x2, y2, right? 1 minus negative 1 is on our rise, and then 2 minus negative 4 is our run. So we're going to end up with 2 over 6, right, because these both became plus. And then that's going to reduce to 1/3. So the slope of AF is 1/3. You're going to pause the video here, and I want you to figure out the slope of FH, the slope of HS, and then the slope of SA. Go ahead, pause it here. Okay, so here are the answers you should have got. So for FH, should have gotten negative 2/5. For HS, you should have also gotten 1/3. Now, you probably got this first, negative 4 over negative 12, which reduces to 1/3. So it's important to be able to like reduce our fractions. And then for SA, let's do that one real quick. So we have negative 5 minus negative 1, and then negative 5 minus negative 4. So we're going to have negative 4 over negative 1. So that's going to be just 4. Okay, so you notice that we have two slopes that are the same, and then we have two slopes that are different. So basically we have one pair of parallel lines. Well, the best answer then, the best quadrilateral we can come up with just a single pair of parallel lines is a trapezoid. And if you did this visually, you could probably see this pretty clearly, right? That this line, this is where we got the slope of 1/3 for these two lines. And then these slopes is where we got, this was the negative 2/5, and then this was the 4. So again, Desmos helps if you want a visual. Okay, a key point that we're going to end on here is this is something students often confuse. Having the same distance means that lines are congruent, whereas having the same slope means lines are parallel. Okay, so you can be parallel but not congruent, as you kind of see in this problem. So these two lines were parallel because they had the same slope, but as you can see, one is longer than the other. So just because they both had a slope of 1/3, some students will say, oh, they're congruent, but they're clearly not. Having the same slope means that the lines are parallel. Okay, so slope goes with being parallel, distance goes with congruence. Key point. All right, here's some extra practice opportunities for you that will be linked to the YouTube video and on Google Classroom. You can practice slope on Khan Academy. But other than that, you are ready for the exit ticket. Good luck and have a great day.